This is reading week 14 for Physics 2212. One of the first things that was mentioned in the edX video was that there are different ways that a particle can accelerate, and this is something that I already knew from what we learned last week. However, I was curious and looked into some more ways. The synchrotron in the top right picture accelerates electrons to extremely high energy and can also have them change directions periodically. And the Hadron Collider in the bottom right picture boosts particles and accelerates them to a speed close to that of the speed of light. We then looked into oscillating charges and how to model their acceleration, and the series of equations that we use to do this are on the slide. And in this case, A sub CO represents the acceleration amplitude of the charged particle, and omega represents the angular frequency of the oscillation. To then find the radiative electric field, we have R, the distance between the observation location and the charge source. Then we found the acceleration perpendicular to R and its corresponding radiative electric field. This field oscillates parallel to A sub C perpendicular. And we can use the equation on the slide, and this also gives us the B field, which is just the magnitude of the E field divided by the speed of light. And these two fields are going to be perpendicular to each other. We also reviewed some things that I already knew from my basic chemistry classes, which are the properties of waves. Period is the time it takes for one cycle to occur or one repetition. Frequency is the number of waves that pass a given point in a specified time period, and that can also be made into angular frequency by multiplying the frequency by 2 pi. The wavelength is the distance between identical points in the adjacent cycles or repetitions. Then we talked about what I thought to be the most challenging part of this week, which was that charge can be set into motion by interacting with another source of EM radiation, and this will cause the charge to oscillate from the electric fields of the incident radiation, and this causes the charge to radiate as well, which is called re-radiation. And to find the net radiation, this would be the superposition of the incident radiated electric field and the re-radiated field. As for external resources, I looked at the student wiki and I also looked at some pictures like the one on the right, and this helped me visualize things a little bit better. As an environmental engineering major, we learn a lot about environmental risk for EM radiation, and just one example of this would be that at higher energy microwave radiation at certain frequencies can be carcinogenic and cause thermal effects that increase the temperature of exposed organisms.